properly. Good. Thank you. Thank you very much.
Oh, stop sharing.
Okay, good. Thank you very much. Columbia and Coleman. Seminario virtual La economía circular como vía hacia la inclusión, soluciones para los territorios. Es un honor y un placer saludarlos en nombre del Instituto de Investigación en Ingeniería y la Facultad de Ingeniería de la Universidad Cooperativa de Colombia. Me gustaría mencionar que este espacio es organizado por la Universidad Cooperativa con el apoyo del Instituto de Investigación de Ingeniería, como lo mencioné, y también la Facultad de Ingeniería del proyecto CELICE, el cual es financiado por el programa Horizonte 2020 de la Unión Europea, y también contamos con el apoyo de la red Verstic en Ciencia, Tecnología, Innovación y Cultura. Hoy nos reunimos para explorar un tema de gran relevancia e impacto: cómo la economía circular puede ser una herramienta poderosa para fomentar la inclusión y generar soluciones sostenibles para los territorios. La transición hacia un modelo de economía circular justa no solo busca la eficiencia en el uso de recursos, sino que también se plantea como un camino hacia la creación de oportunidades equitativas y el fortalecimiento de comunidades. Durante este seminario tendremos el privilegio de escuchar a un grupo de expertos destacados en el campo de la economía circular y el aprovechamiento de la madera, quienes compartirán sus conocimientos, experiencias y propuestas innovadoras. Sus aportes nos permitirá comprender mejor cómo aplicar estos principios de manera efectiva para contribuir al desarrollo local y regional. Vamos a tener unas cortas exposiciones de 7 minutos para cada experto y al final un espacio para conversar alrededor de estos planteamientos y las oportunidades de transformar estos retos. Antes de esto, yo quiero darle la bienvenida a nuestra decana, la doctora Adriana Villegas, de la Facultad de Ingeniería, de la Universidad Cooperativa aquí en la ciudad de Medellín. Decana, bienvenida.
Buenas tardes, Fernando. Doctor Fernando, qué gusto saludarlo y qué gusto saludar a todos sus invitados en este evento. Y muchas gracias por la invitación.
Muchas gracias, decana. Bueno, sin más preámbulos, quiero agradecerle a todos por su participación y dar paso a nuestros expertos para que comiencen a compartir sus valiosas perspectivas y conocimientos. También me gustaría que en su momento la decana nos hablara de 2 maravillosos doctorados que fueron aprobados por el Ministerio de Educación de Colombia, el doctorado en Ingeniería y el doctorado en Sostenibilidad, aquí en el campus no solamente es el campus de Medellín, está en Bogotá y en Bucaramanga, sí, unos doctorados que están muy alineados con estos temas que estamos trabajando acá y conectados con las prioridades de nuestros grupos de investigación y también del Instituto de Investigación con estos aliados internacionales. Voy a leer los perfiles de nuestros expositores. Sí, nuestra primera persona que va a exponer es Laura Anse. Es doctora en química física e investigadora principal y gestora de proyectos en el laboratorio de celulosa del Instituto Estatal de Química de la Madera de Letonia. Durante más de 10 años, incluyendo incluyendo su investigación doctoral, se ha centrado en la creación de materiales de embalaje de papel a partir de madera y biomasa, mejorando al mismo tiempo sus propiedades mediante sustancias naturales, en particular el quitosano. Su trabajo consiste en extraer quitosano de recursos locales y modificarlo para diversas aplicaciones. Además, estudia la extracción de nanocelulosa a partir de madera y otra biomasa, explorando sus usos potenciales. Actualmente dirige 3 proyectos internacionales en su instituto. El proyecto que es patrocinado por el programa Horizonte 2020 CELICE, del que le estoy hablando, que hacemos parte de ese proyecto, que colabora con instituciones europeas y latinoamericanas para compartir experiencia en el uso de biomasa para envases y materiales de construcción, al tiempo que se apoya a las zonas rurales. El proyecto Horizon Europa Bioacois, centrado en el desarrollo de paneles acústicos a partir de fibras de biomasa, y está el proyecto Rain Vapor, que incluye el desarrollo de sistemas de filtración de agua a partir de materiales de fibras de biomasa y biopolímeros, así como la creación de materiales biopoliméricos, electrospun que incorpora quitosano, ácido sulfúrico y nanocelulosa. Recientemente ha asumido un nuevo reto de investigación colaborando con colegas del Centro de Microcirugía de Letonia y la Universidad de Strandis de Riga para desarrollar implantes de osteosíntesis hechos de madera densificada. Sí, la doctora Laura también es subdirectora del Consejo Científico del Instituto Estatal Letón de Química de la Madera. Bienvenida, doctora Laura. Voy a también a todos los perfiles los voy a leer en este momento, sí, para que tengamos toda la, digamos, la consecución de nuestras exposiciones. Anita Bronca viene de Polonia, es estudiante de doctorado en la Escuela Doctoral de la Universidad de Ciencias de la Vida de Varsovia, en Varsovia, Polonia. Anita es ingeniera en diseño de muebles y máster en tecnología de la madera por la Facultad de Tecnología de la Madera de la Universidad de Ciencias de la Vida de Varsovia. Su tesis doctoral se centra en el reciclaje de materiales derivados de la madera, principalmente tableros de partículas, carpintería de ventanas y puertas post-consumo y tableros de fibra de densidad media y alta. Su investigación se basa en los principios de la economía circular. Se caracteriza por unas condiciones de ensayo totalmente controladas para poder identificar con mayor precisión los factores limitantes del reciclado de materiales de madera y la propia madera. Actualmente es el jefe del grupo científico de estudiantes Koło Naukowe Meblarstwa de la Facultad de Tecnología de la Madera de la Universidad de Ciencias de la Vida de Varsovia, SGGW, en polaco sería, y miembro del Consejo Doctoral de la Escuela de Doctorado de la misma universidad. Bienvenida, Anita, y voy a leer, estas son las dos primeras exposiciones, lo vamos a hacer de esa manera. Laura, vale, estas son las dos primeras exposiciones. Tenemos también, qué pena con ustedes, se me cerró acá sin querer. A ver, voy a leer el del profesor Regos Kowaluk. Sí, las segundas dos exposiciones está el profesor Regos Kowaluk, que es ingeniero en tecnología de la madera con un máster graduado por la Universidad de Ciencias de la Vida de Poznań en Polonia, especializado en el procesamiento mecánico de la madera. Su tesis doctoral que defendió en la misma universidad contribuyó a sus conocimientos de ingeniería, ya que se ocupó de la fracción y las fuerzas de corte durante el fresado de compuestos a base de madera. Amplió sus conocimientos de ingeniería y organización en el Instituto Tecnológico de la Madera de Poznań en Polonia. Fue jefe de proyecto de materiales compuestos fabricados con una nueva forma de materia prima, virutas fibrosas. Ahora en la Universidad de Ciencias de la Vida de Varsovia, SGGW, es responsable del proyecto de Horizonte 2020, CELICE, que les mencioné de Laura también, y de un proyecto internacional de la convocatoria Forest Value 2021 Bar Building. Participa activamente en el desarrollo de los estudiantes, tutelando más de 100 tesis de ingenieros y de máster. Su actividad profesional actual se centra en una utilización más racional y óptima de las materias primas, incluida la biomasa, en la tecnología de los compuestos a base de madera y en el ajuste a las tecnologías conocidas de producción de compuestos a base de madera dirigidas a aplicar las materias primas alternativas. Es el inventor de dos patentes, una que es prensado de contrachapado 50% más corto, compuesto a base de madera con materiales de cambio de fase. También tiene experiencia en la conversión de biomasa infrautilizada, como la piel de plátano, de banano, o los residuos post-extracción de granos de café para la producción de madera contrachapada. Bastante interesante. Gracias, profesor Regos Kowaluk, por hacer parte de este gran evento. Y no siendo menos importante, también el candidato a doctor Martins Ans es investigador en el Instituto Estatal Letón de Química de la Madera en Riga, Letonia, con formación en Ingeniería de la Madera y un máster en Tecnología y Diseño. Su investigación principal se centra en el uso de métodos de pretratamiento por explosión de vapor para producir fibras a partir de madera y biomasa vegetal, que se utiliza como materiales aislantes a granel. También estudia las propiedades físicas, mecánicas y de resistencia al fuego de materiales aislantes y tableros de fibras y trabaja en la producción de tableros sin aglutinantes. En su investigación reciente se han centrado en el método de explosión de vapor para extraer prebióticos para aplicación animal a partir de distintos tipos de biomasa, con especial énfasis en los residuos agrícolas. Martins se interesa especialmente en la modificación de la madera mediante tratamiento térmico para crear astillas que puedan sustituir a los barriles de madera en la producción de bebidas alcohólicas. Además, diseña y fabrica diversos equipos científicos. Como propietario de una nanofábrica de cerveza, disfruta elaborando cerveza artesanal y desarrollando nuevas recetas. También se ocupó de cuestiones relacionadas con la protección de la madera, prestando servicios de control de plagas, especialmente carcomas, mediante fumigación. Actualmente lleva a cabo investigaciones científicas tanto para proyectos de la Unión Europea como locales. Es autor de 3 patentes y ofrece servicios de consultoría a empresas dentro de su área de especialización. Próximamente defenderá su tesis de doctorado el 12 de diciembre del 2024. Mucha suerte con eso, Martín. La cual se titula, abro comillas, material aislante térmico de relleno suelto obtenido a partir de agramisas de cáñamo por explosión de vapor. Bienvenidos a todos, ¿sí? Y vamos a empezar con Laura, su exposición. Laura, the floor is yours. You can start now.
Thank you for your introduction. It was good that I understand part of what you said. So I will share my presentation. So Fernando already said, so we are from Latvian State Institute of Wood Chemistry, and our mission is to develop a competitive materials and products from wood and other biomass with scientifically based, environmentally friendly, low waste technologies. And our vision is to become, as Baltic Bioeconomy Excellence Center, what will promote biorefinery as the backbone of future industry and wood as modern, sustainable building material, and reducing the use of fossil resources and achieving Europe 2050 zero emission goals. So we are founded in 1946. We are more than 100 employees and 40% with doctoral degree. Our research activities for our institute is paper and packaging, so cellulose used of natural polymers, recycled materials and composites, then building materials, transportation, what we understand with bioethanol, fuel cells in electric cars, green hydrogen and other energy, then green chemistry, sugar derivatives, phenols, furans, different polymers, then materials for health and well-being. So it's biologically active compounds from biomass and wood, antioxidants for food and cosmetics, and wood bone implants, then energy, then looking after air environment. So there's sorbents, filter materials, materials for plant growth and plant protection, and high education, so information and knowledge share with industry and higher education schools. So, it's not going further. So our organization structure, we have 6 laboratories. There's a wood protection laboratory, bioengineering, polymer laboratory, cellulose laboratory, laboratory of biorefinery, and lignin chemistry. I have problem with okay. So I'm from cellulose laboratory, and our research directions are to obtain and study cellulose fibers, like chemical and mechanical biomass pulping, characterization of cellulose, and fiber modification. Mostly it's used for packaging materials. Then research and development of pressed cellulose fibers like cardboards and molded paper packaging like egg box or for transportation. Then obtaining of microcrystalline cellulose and nanocellulose, mostly used in cosmetics or in packaging like in transparent films. Mycelium composites, what is, I will explain later more about mycelium composites, and densified wood materials for osteosynthesis bone implants. And this is a new direction for our laboratory and for institute to modify wood by cooking and compressing. And this way we can get a high density material, 3 times dense, and higher strength and elasticity, what is compared with bone. So our idea is to produce osteosynthesis implant materials, what is to connect together bone when it's collapsed. So it's for medicine and to use instead of metal implants. Okay, so about current cooperation with Colombia, we have worked with Fernando few years ago on characterization of cacao wood branches as potential resource for paper production, and we find out that it's really good resource here in Colombia to use it like packaging material to produce paper and use it for like paper bags or for card box. And our next step is high performance material from densified wood from cacao and coffee prunings. So we hope to produce similar material with high density and mechanical strengths to use it in constructions. And about mycelium composites. So this direction, from my opinion, is interesting and quite easily usable in rural areas. So mycelium biocomposites are made from 100 natural, inexpensive raw materials. So it's local agriculture and forestry residues, such as hemp sheaves, straw, wood chips, waste paper, and it could be even cacao bean pod husk, cacao and coffee prunings, bamboo, corn stalk, and then we can make some kind of fibers or small particles from this local agriculture and forestry residues, and connect all together with fungal mycelium. So we are growing fungal mycelium and mixing together with this fibrous material, letting to grow this material for 2 weeks, and finally we can get like biocomposite, what you can see in the pictures. So this mycelium is working like a glue, connecting all these fibers together. So you can produce packaging, secondary packaging. It's really light material. It could be acoustic panels, and now we are testing this material for water filtration systems. And so what we offer and what we are looking for from our institute side. So we offer research in the field of non-food bioeconomy, wood science, biorefinery, cellulose, lignin chemistry, biotechnologies, thermolysis, polymer chemistry and technology, different analysis and tests, workplace for students, including foreign students, develop their research work, upscaling processes and organization of conferences and summer schools. And we are looking for engagement of the scientific and innovative capacity, increasing the opportunity for international and intersectoral cooperation, common research and joint projects in the field of non-food bioeconomy, wood science, biorefinery, and all other cooperation for Horizon Europe projects, Maronet, and other different possible projects. Industry partners as customers interested in our expertise, and researchers and students ready to work in our team. So thank you for your kind attention.
Thank you. Thank you very much, Laura, for this beautiful presentation and opportunities based on the biomass that is very typical here in Colombia, cocoa and coffee biomass. Thank you very much for that. Now, Martins, please, you can continue with the presentation.
Hello, my name is Martin Čanč. I'm from Latvian State Institute of Food Chemistry. Today I want to present something wrong. Should wait. Presentation is slow. I'm a part of the laboratory of biorefinery. We have a lot of different works what we do. The basic replacement of fossil fuels and energy sources with biomass included wood, raw materials, and different other materials, creating fundamentally new products with high added value or improved properties. The efficient use of biomass and the diversification of the biorefining system, where the principles of the cascade are followed. Biomass is primarily used to obtain a higher value product, and the byproduct of this process is the raw material for the next processes. Laboratory of biorefinery. They have different parts of this laboratory. Now I present what we do there. One of the catalytic pretreatment with the furfural and oxalic acid extraction and lignocellulose preservation for the development of fibers and second generation biofuels, biobutanol, bioethanol, And basic for me, my thesis is working with steam explosion pretreatment for the obtaining self-bonding composite materials and thermal insulation materials. Thermochemical conversion of lignocellulose into the anhydrous sugars, levoglucosanine, with emphasis of the development of new end products. Biomass carbonization, activation, and doping to the obtained carbon materials, catalysts for fuel cells, and the electrodes for the supercapacitors and lithium batteries. One of the biggest part of our laboratory, we working with different barks. Extraction of birch bark is basic for us and very important for Latvia. We purification, we modificate of the tiny betulin extract and development of new triterpene-based products. We get dry extractives, hydrogels, oleogols for cosmetic use, food supplements, medicine, and depolymerization of extra birch bark, modification and purification of the obtained suberin acids for the development of new products. From suberin acids we get adhesives, coatings, impregnations, films, polyols, additives, and other materials. Improving the properties of wood and wood materials using thermo treatments. We have very big companies who make plywood, and this thermo treatment is very important for our country because we have a lot of problems with woods because we have high level of humidity, a lot of different bugs, and we need protect this wood. And we tested different friendly binders for wider use in constructions. This is my basic work, steam explosion treatment. And I think last days what technology will be acceptable in Colombia, and what will be the easiest way to integrate like a technology for different uses, and the steam explosion is one of them. You see, for this process you need only water. This process is making different fibers for corn stalks, for wood or other materials, and it's for the process we need only clean water, pressure, steam, temperature, and then you get different materials. In the first you see this to the right side, this hemp chives after processing long fibers, and when you treated these materials more deeper, you can get more fiber and materials. But if this treatment is too more, you get like a PT part, like an alternative for agriculture. One of the material what we get in this technology is fill-in heat insulation materials. This is eco-friendly loose fill thermal insulating materials for building insulations from local crops, residues such as wheat straw, buckwheat husk, corn, and reed stems. In Colombia, I think it's called. If I look at the literature, cocoa pod husks will be acceptable. Important in Colombia, the purpose of insulating is not only to save heat but also to save cold. Installing insulation in buildings can help keep climate change in the rooms to a minimum. It's mean if you insulating your home, it's your temperature at at your home, it's changing in all time of day, only in approximately 2-3 degrees. And these insulating materials have very high insulation heat capacity. It's mean for your very like high temperature weather, its natural materials will be the best insulating materials. One of the technology, one more, what you can make from this steam explosion treatment technology, you can make binderless boards. It's mean you don't need like a formaldehyde bonded resins. You need only this treatment in a higher temperature. How you see 201 minute or 2 minutes is different in colors, but all these boards making sticking together, bonding, and like a resin is it's lignin, and it's boards you can use at building constructions and furniture. It depends what kind of steam explosion treatment you like treatment this material. Of course, this lighter you can use in like in furniture, but darker you can use. It's more stable and more stronger in construction buildings. And one of the newest project what we think last year, it was use of innovative prebiotics in poultry and crop production to achieve climate neutrality. From the steam explosion, this method, you can get out antioxidants and xyl oligosaccharides. It's a very good for chicken and beef production. And you can get more healthy chickens, more healthy beef, and you can get more stronger eggs. And for if you use for feeding these chickens or beef, you get higher quality meat, and this is very important for like people's healthy. Thank you.
Thank you very much, Martin. Very interesting your presentation. We have already some questions, but this is going to be at the end of the whole bunch of presentations. Okay. Now I would like to give the word to the dean or our faculty, Doctora Adriana Villegas. Please, you can start now. Thank you.
Thank you. Thank you, Dr. Fernando. A very special greeting to all attendants. It's a big pleasure to be here, and my gratitude to the speakers for sharing their knowledge and research advances with us. Now we are going to introduce the general proposal for the doctorate program in engineering, which is about to begin academic activities. The doctorate has 3 lines of research. The first is energy, water, and environment. Second one, material structures and soils. And third, information and communication technologies. Here is quite important to highlight that the most important topic for us in this doctorate is the impact in the territories and the contribution to the development of the public and private industries. For that reason, our program is going to make a difference compared to the other proposals. And it's important to say here that our doctorate will be carried out in Bogota and Medellin. But it's fundamental that you know that our university is a multi-campus university with a big impact in all regions of our country. For that reason, we have many researchers around the country, and the idea is connect uh, researchers inside our country with other researchers like us, you, for developing different research projects that can impact uh, regions not only in Colombia, in any regions of the world. Um, Also, it's important to highlight that the ADN of our university is the solidarity. It's for that reason that our proposal is focused in that aspect, impact and development. But it's not the only PhD that we have in this moment. We have been work with the Red Mutis, Fernando Grijalmi, Network Academic Mutis, that's the correct number in English. And the idea, we work in a PhD in sustainability. This PhD, this doctorate already, and this doctorate is will be available for students in 3 campuses of our university: the campus Medellin, the campus Bogota, and the campus Bucaramanga. We are engineers. Sorry. For that reason, the focus on the topics of sustainability will be climatic change. That will be our focus. And for your presentation, I can anticipate that will be easy that you joined with our work in these doctorates. I don't know, Dr. Fernando. um, I don't know if you say something additional about this general proposal that I present in here in the time that you give me, 3 minutes.
Thank you very much, Dr. Adriana Villegas, the Dean of the Faculty of Engineering here in our campus in Medellin. So we really put a lot of effort to get that PhD approved in engineering, but also in sustainability. We have right now 2 doctorates, for the UCC, and the idea is really was to add value to the territories based on the needs that they have. Okay, but also the potential. You were talking about the biomass. A lot of biomass available that can be converted in a business model. Of course, we need to understand how we can make it, but also you need to include, the communities that are living in rural areas or indigenous community, as we have the opportunity to travel off with Regos, Anita, also Laura and Martins, and to understand really the potential, but also the community that can take over, that knowledge or make the appropriate transfer of that knowledge to those communities, but also to the industry. Today we have the opportunity also, Adriana, to be in the EPM facility
Yes.
And there were some projects around, circular economy, very interesting, based on biomass, but also energy transformation. Yeah, as well as artificial intelligence and using these digital platforms. But this is the doctorate. I mean, you get the knowledge, of course, but you need to apply this to real problems. Yeah, no, of course, the publications, patents, and so on are important. But for us, as the university that have the presence, as Adriana said, that is in different cities throughout Colombia, 19 cities. Okay, so our priority is really to make that transfer to the local, regional partners that are there. Okay, of course, well aligned with the national institutions. Okay, so this is the thing that I really wanted to highlight or point out, that is also, for instance, in the engineering doctorate, is a very multidisciplinary doctorate, despite that we have, the emphasis on energy, and water, environment, okay, also ICT technology, okay, and the product development. Also, we have materials, artificial intelligence, automatic systems, but also with our sustainability doctorate is very interdisciplinary. And we are collaborating with other universities, and this is the idea, to share the knowledge and gather, the international partners. Thank you very much for that, Adriana. So I can give more detail later on.
Fernando.
But thank you for being with us in here. I know that you have a very tough agenda today. You have other commitments, but thank you really to be part of that seminar or webinar. Thank you. Really appreciate that.
Thank you so much.
Okay, now thank you very much, Adriana. Now the turn is to Professor Grzegorz Kowaluk. Please, Grzegorz.
Okay, thank you very much for invitation. And first of all, I would like to say thanks for Project Celize, that we are partners of that. And also, of course, great things for Professor Fernando for invitation. We are very happy to be here. And let me introduce myself. My name is Grzegorz Kowaluk. I am from Warsaw University of Life Sciences. And let me introduce you to our university, and then I will ask Anita to say more about the biomass and how we are connected to that project. And yeah, first of all, okay. We are from Institute of Wood Science and Technology, and we are working mostly with biomass, but generally with wood. And let me tell you later what's our interest in Project Celize, and I will tell you some words about our equipment, our possibilities to collaborate. And our university has more than 200 years, and we have more than 18,000 students and more than 1,200 professors and doctors. And yeah, we have the campus located in the Warsaw, so with good connection to be there. And we have something like 70 hectares of campus. And in our institute, we have 3 different departments. We are this last one, Department of Technology and Entrepreneurship in wood technology. Me and my team work with the biomass, with lignocellulosic materials. So we are working mostly in technological that is equipment with different stuff like hydraulic presses that are computer controlled, and some equipment which is used to produce the composites that are mixed with resins, with glues, different type of glues. And then when we produce these composites, we are able to characterize also raw materials, but also the produced composites, the samples, in mechanical properties, physical properties, and so on. And also we collaborate with producers of industrial scale wood processing machines like HOMAG. And what next? We have different chemical treatment equipment like the chambers, which can be used for modification of wood in gases or just in the air. And also we have different chromatographies and also equipment XRF to characterize the wood materials and biomass materials. We have different testing machines, mechanical testing machines, climatic chambers, and equipment to characterize the material of thermal properties, and also X-ray Grecon analyzer to measure the density profile of the produced composites. And also we have a lot of different equipment to characterize the composites mechanically, physically, but yeah, we are actually equipped with all necessary stuff to do the test according to several different standards, European standards, which are applied for that materials. So this will be the part from my side, and if I may, let me ask Anita to continue this speech. Thank you.
Thank you very much, Professor Gregor Kowaluk, for your nice presentation and beautiful pictures. Thank you. Please, Anita. Thank you.
Okay, can you see the presentation? Okay.
Yes.
So I'm a PhD student. It is my last year of PhD. And in my research, I'm focusing on wood recycling, following the circular economy principle. And the main topic of my research is to recycling wood as long as it's possible. And then we try to recycle wood products. And here is the example of this. At the beginning, we have only branches, which we were milling into particles. And then we separate them for particles for phase and core layers and produced the particle board. And then we were checking the properties of manufactured boards. And in this research, main case was to remilling produced particle boards into particles again, and then we try to produce again particle boards. Okay. So as I mentioned, my research are about the wood recycling, and I was following a few scenarios. The first one was about 3-layer particle board production, remilling, and again production of particle board. The second one was about upcycling of birch bark post-extraction residues. The third, upcycling of pine branches into particle board production. The next one, upcycling of post-consumer wood. We were using window frames for particle board production. And the last one will be about thermo-hydromechanical reprocessing of post-consumer fiber panel to form a fiber panel with indication of the possibility of upcycling the raw material. And now I would like to focus about materials in which we were working in our wood products. And for example, we were using eggshell and we were adding them to face layer in particle board. And we were using also coffee grounds, which were filler in plywood production. And in my research, I was working with raspberry stems, and I produced the particle board from them. We were working with Brussels sprouts and cassava starch, and they were also used in particle board production. And we were using also yerba, corkwood, conis, and beeswax, for example, and sisal and nettle. And they were using mostly in particle board production. And as Grzegorz mentioned, we are working in Barfield project, and we are using subarinic acid residues in wood production. And it was used in particle board, plywood, and for example in OSB. And now I would like to show you a short movie from our research, how looks our work. And if you want to know something more about our furniture scientific group, I would like to invite you to follow our social media. And now this is the movie from production particle board from nettle. And here we are mixing the particles with glue. Here also, now we are measuring the mass. And preparing the form. So this is our equipment in practice. And this is all from my side.
Thank you very much. Very nice cake, naleśniki.
Thank you.
Thank you very much. Very, very nice. Thank you, Anita, for your presentation. And I really appreciate that, guys, that you are here in Colombia, in Medellin, with us and sharing all this knowledge via Celice project, our sponsor from the European Union, Horizon 2020. Really appreciate that. We have some questions. Okay. Just we'll check here. Okay, there is one question. This is for Laura. Okay. The results obtained using cocoa biomass are promising. How do you think would be the best path to proceed in order to scale up the technology? In terms of the availability of biomass, could be maybe to build a processing plant here in Colombia. However, the technology developed is from Latvia or Poland, okay? Are you considering to expand and build a processing plant in Colombia? There are two questions, okay? How do you think would be the best path to proceed in order to scale up the technology?
Okay, for the first, if we are speaking about paper packaging, our research, what we did together, I would say for paper production there's one big problem, and it's water, because this technology is using a lot of water. So it's kind of probably not the best way to use biomass. And still there's not so far from you in Brazil, they have the main factories for paper production. If we are speaking about other technologies like steam explosion Martin is working with, or this mycelium biocomposites. So mycelium biocomposites don't need like any big technologies or any big factories. Normally, it could be done even in home. So this is something what could be really be done by people in rural areas, like artisan work, because you can find some like temperature to stop growing this mushroom mycelium, and it's almost, that's all. And you have really great climate, like 25-30 degree for this mycelium growing. So you don't need any other heating like in our country during the winter. So this is really possible to do here. And it doesn't need any really lot of money to work on it. And steam explosion, it's a bit more technologies, and of course then you need to look for some equipment, but it's still cheaper than some other technologies. If we are speaking, if we are going to make something in Colombia, then we are researchers. We can help with our knowledge, but then you need to look for some investors or some industry to help, and I think we would be ready to work and help with our knowledge.
Thank you very much, Laura. And we have today the opportunity, to see a little bit about the dynamics in terms of the investment for this kind of project coming from EPM, the utility company. Mm-hmm. Okay, I got a second question in here. This is in Spanish, but I translate it into English. This is, what strategy policies at the governance level do you recommend for our country, Colombia, in terms of reforestation for the sustainability of the abatement chain in the case of wood co-products and byproducts? Okay, mm-hmm. In terms of the strategy policy, I don't know if Regos or maybe Anita, Martin can deal with that question. Strategy policy, maybe some example from Poland and Latvia that can be applicable here in Colombia. We have that opportunity to talk, remember, about the biomass, the pellets, in the rural areas. So it was very interesting, could be, a very good starting point for that. I mean, before starting, of course, creating these policies, we need to talk about, the end user, with the end user involved in the process. Yeah, but I don't know if you have some ideas around that, please.
Yeah, if I may.
Please, Gregor.
I would like to follow the presentation of Dr. Andrea. Andrea, if I remember properly. Yeah, the dean.
Adriana.
Adriana, sorry. Okay, that we are trying to, if in fact we are taking the profits from the biomass from the forest, but on the other side we need to try to protect these resources. So that's the sustainability, as Dr. Andrea said, Adriana. So that's the sustainability, and I think one idea to make this sustainability can be the forest plantations, and you have very good place to do these forest plantations, because as I know, there is no winter time, just dry and wet period. So as I see your plantations of different wood, they are growing very fast, and it's very nice place to keep these plantations. Other idea is to keep to use the low quality lignocellulosic materials for the composites, as we have experience with that. Because for several materials like particle board, it's not necessary to have a very, very good first quality wood, like for timber wood to make the structures or structural wood, and you can use the low quality wood. So that's my ideas at the moment, how to use the biomass with the different qualities, and that is available here.
Thank you very much, Gregor, for your answer. We got three more questions. Sorry about that, guys, but it's in Spanish, okay? But I will translate into English. I don't know who can answer. Can the process developed in a laboratory or pilot plant be expanded without compromising efficiency or quality? Okay. Who's going to answer that? This is about TRLs. You know, TRLs, if we have a pilot, you know, in laboratory, when you transfer this to a real environment, how do you know the quality or the efficiency will be compromised in this process according to your own experience? You can share it with us, please. Laura?
So if it's about some our technologies, that a lot of them